We'll start example 5 now. This is a really small example just to get practice on using Bayes' theorem. This is a theorem that you should have learned in your statistics course. So this problem is just meant to refresh that, and then we use that theorem in a bigger way in examples 6 and 7 in a much longer problem. But for now, this is a short, simple problem. Go ahead and read through it. Because it relies on some statistics content that you should have learned in a previous course, on Canvas I uploaded a file for probability review sheet. So before jumping into this problem, go ahead and review this handout down to Bayes' theorem. We're going to be using a lot of this notation and a lot of these rules. Before I get started with the problem, I'm just going to organize some of the information that they give me. Okay, I'll let H denote that the team played a home game, or at home, and then a W means that they won the game. They give us a few probabilities, so I'm going to organize those in probability statement. This is something from your previous statistics course, probability statements that we'll use from now on. I'm going to start here at this sentence. Half its games are played at home, half are away. Means probability of a home game is 0.5, and probability of H complement, the horizontal bar above the letter, means not that event, so not at home would be away, is also 0.5. One particular team wins 58% of its home games. Putting that into a probability statement. So the probability that they win, given they play at home, is 58%. Remember, after the vertical bar means that event has already occurred, or it's given information. It goes on to say, and only 45% of its away games. So the probability that they win, given not at home. Our question prompt says, if we hear that this team has just won the game but are not told where it was played, what's the probability it was played at the team's home field? So putting that into probability statement, we're finding the probability of a home game given they won. So we already know that they won. What's the probability it was at home? This is a conditional probability. So I'm going to look at my probability review sheet to find the formula to calculate this. To find a conditional probability, it's the joint of the two events over the given information, equal to the joint probability of both events, so H and W, over the probability of the given information, probability of a win. So this is what I'm trying to find. This is what I have. None of these pieces will work here, so I need to calculate both of these. The easiest way to do that is using a probability tree. This is different from the decision trees that we've been doing in the previous examples. Probability trees are just used to calculate joint probabilities and probabilities of single events, which is exactly what we need. I need a joint probability here in the numerator and the probability of a single event here in the denominator. Whereas decision trees are used to make decisions and analyze monetary value of different outcomes. So I start my probability tree just with a closed circle node, it doesn't really matter, and I branch off with a single event. The single event that I have is whether a game is at home or not at home. And the probability of that is 0.5, 0.5. Next, my two events that are conditional on whether or not they played at home are whether they win. So the probability that they win given they played at home is 0.58. Therefore, the probability that they do not win given they played at home is 1 minus 0.58, or 0.42. Same thing here, if they play away, they can either win or not win. From here I know it's 0.45, therefore this must be 0.55. Remember, both event branches must sum up to 1. Next, we want to create the joint events and then their probabilities. So my joint events I just find by kind of multiplying along the branches, H and W. And I find the probabilities the same way. I'm just going to multiply the probabilities along each branch. So take 0.5 times 0.58. Multiply that together gives me 0.29. I do that along each respective branch. Okay, so now I have a bunch of probabilities for joint events. To make sure you've done it correctly, quickly add up your final probability column, and it must equal 100%. Once I have my probabilities and my joint events, I'm finished with the tree. So I'm just going to erase that actually. I'm going to start with my numerator because it's the easier one. I need the probability of H and W. So the probability of a home game and winning. Find this on my joint events probability, right here, 0.29. For my denominator, the probability that they win. Let's think about this logically. So logically, a team can win two different ways. They can win and play at home, or they can win and play away. To find the probability of this, probability of winning, I'm going to translate this to probability statements. I want the probability of winning and playing at home, or in statistics, translate to plus signs, or winning and playing not at home, playing away. So I find these two probabilities on my table over here, 0.29 plus 0.225. Or maybe a simpler, faster way, instead of thinking this through, if I want the probability of W, just add up the joint events with W in them. So that's my denominator here. Calculate that, and I have a final probability, 0.563 for my final answer.